Okay, so this might be a slightly longer video, but I just want to go over the most important parts of M1. So in M1, you learn about variables. Okay, so what are variables? Well, you can say that variables are placeholders for data, but also one way to think about it is that variables can help you keep track of things. Okay, I think the second point is more intuitive, but it'll become more apparent as we go forward in the course. So for example, in our turtle and world examples, what are we keeping track of? Well, we're keeping track of the world, right? So once we created a world, let's say W1, right? We created a new world. Now we're using W1 to keep track of that world, to gain a reference to that world. Now, what if I have another world, W2? Well, then W2 would keep track of that second world. So imagine if we didn't have variables and we just created new world like that, then there is no way for us to access either of those, because once we created it, then how the heck do we get a reference to those things? We didn't even name it. And so variables are a great way to name stuff, to name data, and then they also help us to keep track of things. Same thing with turtles, right? So turtle T1. Okay, so now here is where variables come in handy, because now the turtle needs to know which world it needs to go in. And so if I want to put it in W2, the second world, there it is. If I want to put it in W1, there it is, right? So I can use either W1 or W2 to my advantage. And then later on, right, when I'm calling T1, for example, dot turn, then I'm calling the turn method on T1, which I'll talk about later. Okay, so the next thing is, real quick, I just want to show you how to create variables, right? And just let's do a little review. So to create a variable, we need the type of that variable, space, name of that variable, space, equal sign, and then the value. Okay, so these are just placeholders, semicolon. Okay, so these are just placeholders, and then you have to put in the right things for them. Now the name, we can give them whatever. There are naming conventions, but usually variable names start with lowercase letters. Okay, so just as you see here, they are not uppercase. Okay, uppercase is for classes, which we will see. So you should have, okay, let's just take the turtle as an example. So it should start with a letter, a lowercase letter, a lowercase symbol. Mostly you'll probably want to use some English letter, lowercase English letter. You cannot start with numbers. Maybe you could start with underscores, but you probably don't need that. So T1, right? And then the type, well, turtle is a type. The world is a type, and we will talk more about that later. And these are types because people have defined them. So they wrote the code and they said, hey, here's a type called turtle. And why do we even bother about types? Because variables need to have types in order to define what they can do and what properties they have. So for example, for a turtle, right, you can do t1.turn, and I don't know, maybe like 10 degrees, right? So T1 is a turtle data type. Okay, we say it's a turtle that can do turning, I can go forward, that can draw, right? Things like that. But for example, if I have a primitive type, for example, an integer, right? Integer a, I can't do a.turn because it does not make sense for us to do some turning on an integer. Okay, so that's the reason why types are so important, because variables need them to know what they can do, what values they have, what value is valid for them to hold, for what data is valid for them to hold, and then also what properties they have. And again, some of these we'll go dive more into later, but if you read the textbook, you should kind of have a slight understanding about this. Okay, what are the primitive types? Okay, so we've talked about the reference type turtle as an example, but what are the primitive types? So the primitive types, integer, right? Int stands for integer, and that means that variable must be a number, a whole number. Okay, so whole number. What about Boolean? Well, Boolean holds either a true or a false value. Okay, so a Boolean cannot hold 1 or 0, okay, because a Boolean value is not an integer. What about double? Okay, double, this is a strange naming. I'll actually put it here. I have char in between, and we will get to that later. But what is a double? Double stands for double precision floating number. Okay, all that's really saying is that it's a pretty precise decimal number. You'll probably learn later on that computers can't really hold decimal numbers really accurately, and so they need to define a way to hold smaller decimal numbers versus bigger decimal numbers. Bigger decimal numbers take up more space in the computer. Smaller decimal numbers take less, but the trade-off is that a double can hold a much bigger decimal in terms of how many digits are after the decimal point. Okay, so really that's all you really need to know. We'll just be using double in Java for most of this course. So you can, for example, remember as a decimal number. Char C, okay, so a character, is a single letter. You can think of that for now. Okay, and so it must be inside of single quotes. Otherwise, it's known as a string, kind of. So a string is just a bunch of characters. And the reason why it's called a string is because it is a string of characters. Okay, so strings, they hold a bunch of text and they are surrounded by double quotes. Okay, so technically anything that you put into these double quotes counts as part of the text. And so this counts as text. Even if you put 23 into those double quotes, the 23 now is text. It is not a number that can be added. Okay, so the way that you add a string versus a number is different. Now you'll notice that string starts with the capital case, and all of these other primitive types, they start with lowercase. And there's a reason why. Because those things that start out with the uppercase letter are called the reference type. And I believe the textbook goes more into this, but I will also have a video talking more about reference types and primitive types and how they store data a little differently. Hey there, this is Alex from the future. So actually, I just wanted to briefly introduce you to memory diagrams and memory maps so that you have a good mental understanding of what's going on behind the scenes when we create variables and create objects and things like that. So again, there are two different types of variables, right? The first one is primitive types, and then there's also reference types. But we'll just talk about primitive types first. So when we draw a memory diagram or memory map, and when we create variables, specifically when we create variables, you will want to start off by creating some of these boxes, okay? So A holds the value of 5, okay? So this is how you can visualize variables being created. So A is a box, so whenever you create a variable, you draw a box, and then you put the variable name under it. So because A is a variable, I put a box, and then I put the value, whatever it is, inside of there. Okay, now something I also didn't mention is that this equal sign right here, what that means is not equality, right? It's not your typical math equal sign. It does not mean A equals 5 necessarily, okay? I want you to sort of wipe that out of your memory when it comes to computer science, and I want you to read that as gets the value of. Okay, so how is that different from equals? Treating this as equals implies that A is tied to 5, okay? That is not changeable. But that's not how variables work, because variables, as the name suggests, it can vary in its values. Its value is variable. Like you can change up A's value anytime. For example, if I just do A gets the value of 6 now, then it will have the value of 6. So it's not always, so that just means that you can always change the value of a variable. It does not mean equality. Okay, so this equal sign means you can kind of imagine it like an arrow like this. A gets the value of 5. So you're putting 5 into the variable A. This is not necessarily how people say it. So the correct terminology of this might be one, you could say, here, actually, let me draw it over here. Assign A the value of 5, or assign 5 to the variable A. Okay, so you can say it either way. We'll probably know what you mean, but this is one way that you can represent a variable in a visual way. Okay, and now let me show you something. So if I now move this down a little bit, and let me just move things around a little bit. Okay, so now let's say I create another variable called b, and I assign it to the value of a. Then here we are. So when we start creating a variable, we say b, okay? And as you can probably tell, because b gets the value of a, so we look at what is inside the box of a, and we get the value 5, okay? So now these are two separate things. This does not mean b is directly tied to a. And having this as equal sign, as equality, implies that b is tied to the value of a, so that if a gets changed, then b also gets changed, which is not the case at all. So now if you assign a to the value of 6, or sorry, assign a the value of 6, then a will become 6, and b now still holds the value of 5, okay? Now for reference types, things are a little different. So let's say I create a one turtle, T1, new turtle. I'm not going to care which world they live in, just the same world. And then now I go turtle T2, assign the value T1. Then first of all, I know that whenever I create a variable, I need to put T1. Okay, and then that thing, now the way that objects work is not directly put the objects inside of the box. And as you'll see, because it wastes memory and you can reuse some of these objects. So we divide this into simple memory and complex memory. If you've heard of the stack, all variables will live on the stack, and then all objects will live on the heap. This is not necessary for you to understand in terms of the terminology, but if you've heard of these, this will add value to your knowledge. So instead of putting the turtle directly inside of T1, what we want to do is actually create that turtle object inside of the complex memory area. Okay, so here's T1. Okay, and now what we do is when we see this equal sign, the assignment operator, by the way, so this is the assignment operator, it will say, okay, so T1 is going to get the value of this object, which means it will actually point to that object. Okay, so this is a turtle object. All right, and now when I create T2, because T1 is a turtle object type, that means I do the same thing. So I do T2, and then I draw an arrow to that same object. Okay, so T2 gets the value of T1. What is the value of T1? Well, you follow the arrow and you go, okay, so there's that thing. And then so I get the value of that, which points to the same object. So guess what? Let me move this first. So guess what? Now T1 and T2 represent the same object. So they're like two separate different labels, but on one object. So if I do T1 dot forward by 50, and then I do T2 dot forward by 50, in the end, we just have one turtle that first moved forward by 50. So it moved forward by 50, and then it'll move again by another 50 because T2 and T1 point to the same thing. Okay, so that's how it works. If you want to create another instance or another object, a separate object, then you would have to do another new turtle. Okay, so whenever you see the word new, you're literally creating a new box in the complex memory area. Okay, so in this case, you would be creating another turtle, and T2 will now instead pointing to that turtle, okay? So I will put it back to how it was before so that you can see that particular reference, but this is how reference types work. But that's really all I want you to know for now, is that there is a difference between the reference types and primitive types, okay? Primitive types, basically they hold more primitive things that the computer can hold pretty much right away, whereas reference types, they're more complex. For example, to store a string of characters, it needs more code to hold it together, and it can also do other things. Like the turtle, for example, the turtle can turn and all that, and S, there are some commands, there's some methods that we can call on it, and I'll just write a random one for now. Okay, so you can do stuff to reference types that you can't really do to primitive types. Okay, so anytime that you see a type with the uppercase letter, that means it's a reference type. And underlying that type is a lot of complicated code. Okay, now notice that these things are variables. And based on our syntax, okay, so the word syntax, okay, the word syntax means how do we express something in a language that is grammatically correct, okay? So in Java, to create a variable, you must do it in this format, in this syntax, okay? So you can also think of syntax as format or grammar, or more like grammatical rules probably. Okay, so the way you write them must be a certain way in order for Java and the compiler to understand what's going on. Okay, now let's jump to methods real quick. So in your own words, what is a method? So a method, you might say, okay, it's a block of instructions or statements that achieves a specific task. Okay, so you might say it like that. Now, if I were to say call method, what does that mean to you? Okay, so we want to come up with synonyms for both of these so that we can maybe put some of these things together that are foreign to us. So methods, if you look at the definition for this, it kind of sounds like an action, right? An action or a command or a function or an operation. Okay, so there are many synonyms that we can equate with the word method in computer science. So then what about call? What verbs can we put in front of these words so that they make sense? Well, you can say run action, execute command, okay, or run, you know what, here, let's do run function, perform operation, okay? And so any one of these works. So run action, run command, run function, run operation, execute action, execute command, execute function, execute operation, perform action, and so on and so forth, okay? So that's what call method means. So a method is like an action, it's like a command. It represents a block of code that does something, okay? And then calling it means to run that action. Okay, so I hope that makes sense. Now, how do you actually call a method? What is the syntax for calling a method? So the way you call a method is you put the thing that you want to call it on. You know what? Since we've learned variables, I'm not going to use thing. Instead, we're going to use the word variable. To be more precise, it's more of an object, a variable or object, dot, method name, and then parentheses. Okay, so these parentheses are extremely important. That is how you differentiate between a method and a variable. Okay, notice that all these variables, T1 and so on, and then S and B, none of these have parentheses after them. If they do, it's on the methods themselves. Okay, so T1 does not go T1 parentheses because T1 is not a method. It is a variable. Okay, so I need you to have the understanding. So how can we follow the syntax? Well, T1 dot forward, let's do forward, is a perfect example of this. So T1 is the variable name, forward is the method that we wanted to call with, and then by having by putting these parentheses and then following it with semicolons. That way you're running the command, you're running the action, you're calling the method. Okay, now sometimes, we see that we could optionally put some stuff in it inside of the parentheses. And so in here, inside of the parentheses are arguments. Okay, and then you might be thinking, okay, what arguments? We are not arguing with it here. Sometimes we do argue with our computers to no avail, but arguments are just another word for input. Okay, they stand for inputs to a method. Now, the purpose of arguments is so that it could customize and change the behavior of how a method behaves. Okay, in other words, you can also think of this as change how a method runs, change how the command runs, customize the command. Okay, so throughout this course and in your computer science journey, you will come across a lot of different and strange words that now are defined differently than what you're used to. And in those cases, what you want to do is try to come up with synonyms for those words so that you can make sense of them better. Okay, so how do arguments come into play? Well, for here, right, you know that calling forward 50 is not the same thing as calling forward by 100, which is not the same thing as calling forward by 150, right? And that's all it really means, is that this number or these inputs to these methods, they will change the way they behave. In this case, it will change how much the turtle moves forward by. So it's a very generic statement to say how a method behaves, but you want to try to fit that definition into a specific example so that you can see, okay, so that's really what they mean by changing how a method behaves. Okay, so one last thing is sort of connecting the two together. So we're taking the world of variables and the world of methods. Okay, so what we're doing here, what is it again? So we're creating variables. Specifically, over here on this side, we can see that we're creating objects. And by objects, I don't mean actual concrete objects, because that would be crazy. We are creating software objects that represents some unit that either we have defined or other people have defined. So in this example, the world represents a unit or a canvas where we can put the turtle on and you can use the turtle to draw stuff on. A turtle is the thing that we use to draw on a world canvas. Okay, so these are software objects that have predefined functionalities and properties. Okay, so now just real quick, I want to show you what this means. So what this part means. So you might be thinking, okay, so we just talked about methods, right? And methods always have parentheses after them. So does that mean that world is a method name? Yes and no. So it goes into something called constructor. And I just need you to know that, first of all, this is how you create an object, right? It's to say type, variable name, and then new. Okay, so new is the thing that will always be there when you want to create a new object. It'll always be new. This new keyword, so this keyword in Java, it creates an object for you. And what is that object? Well, it's a world. And then what are these parentheses doing here? So that's something called a constructor. And we don't have to dive too deep into constructors, what they do and how they're defined. But constructors, first of all, they don't create the object because that's what new does. Instead, they set up the object with certain properties. Okay, so constructors aren't methods, they're just special methods. They're actions. So constructors are actions and they help to set up object properties. Okay, so here's a cool thing, right? So constructors are special methods, which means they can and they don't have, even though they don't have to. So they optionally, you can give them arguments or not. So for the world, the default constructor, which means you don't need to put any arguments inside of the parentheses, will set the world up with a 480 by 640 canvas. Now, optionally, you could give the world some arguments. So for example, 600 by 800. And what this will do, guess what? It will set the world up 600 by 800 canvas. Okay, so these constructors, their code was written by other people, and now you can use them. So you can use these constructors to set up objects in certain ways. Okay, I think that's good for now. If there's something else that I didn't cover, I have a few in mind actually. So we've talked about how to initialize variables, but I haven't really talked about declaring or just simply assigning variables, but we will get to that later, and that's okay. So the main things that I want you to know are variables. They keep track of things. They're placeholders for data. You need to know the syntax for how to create a variable, how to declare or initialize a variable. You should know about primitive types and how they're different from reference types, what reference types can do that primitive types can't do. And then methods. So what are methods? They are actions, they're commands, they're functions, they're operations. And when you call them, you're basically running those predefined commands and actions. So you're calling those predefined methods. Now the syntax for calling a method is the variable or the object name dot method name, and then inside of those parentheses, you need to put arguments or not, depending on whether the method requires you to have an argument or not. And what are arguments? They're just inputs from you to change how a method behaves. Okay, and then lastly, constructors, because they show up right here. Okay, I thought I'd mention them. So constructors are special types of methods, and we will dive deeper into them later, but they don't create the object. Okay, that's what the new keyword does. So you must always have new here. And then constructors, they just set up the object with certain properties depending on what arguments you give them or not. Okay, so those are all the things that I want you to understand. And the more you work on the assignment or do the read and try from the textbooks, just keep these in mind and try to identify, okay, so here is where I'm setting up a variable. This is where I'm creating a variable. Here's where I'm calling a method. Here's where I'm using a constructor. Okay, I see the new keyword. I need to remember that the new keyword just creates the objects, whereas the constructor's job is to set up those objects with certain properties. Okay, and then think about, okay, arguments. Okay, so those are my arguments. I'm going to put them in so that they can change the way that the method behaves.